Meet Deddy Kismana, an instructor specializing in physics and mathematics, with a background in mechanical engineering. Default Text has extensive experience supporting students across national and international programs. He has also led academic operations and helped develop teacher skills in math, physics, and English. In this session, you will learn through a concept-based approach with clear, structured problem solving.
Hello, I am Deddy Kismana. You can call me with Mr. Deddy or Kak Deddy maybe. I experienced as a tutor in math, physics, and English. I graduated from mechanical engineering of Diponegoro University, Semarang. Okay, today we want to learn about the movement and position. This is the basic of physics. Okay. First, we think about a force. What is a force? A force is a push or pull in a specific direction. So we can define a force is a pull or push in a specific direction. Okay, we can pull or push. This is a force. So, and then a force. This is a force. A force can apply. Next, force can apply in same or opposite direction. We can underline this. Why force can apply in the same or opposite direction? Because I can explain with simulation like this. An object when we apply a force, this, and then it is given another force in same direction. This is same. This is number one, same direction. Okay. This we can initial by this is F1 and this F2. Right? So totally, how sigma F equal with F1 because the same direction we totally with F1 plus F2. So this is bigger. Force become bigger when applied the same direction. Next, number two, in opposite direction. Okay, when an object applied different or opposite direction. This one F1, this one F2. So totally sigma F equal with F1. Sorry, we can plus. This is when right position, when right direction. This is F2 minus F1. Okay. Next, I want to explain about motion. When an object is applied by force, so the object will be move or motion. So what the motion? What is the motion? When an object change position. When the object change position over time. When compared with a reference, when compared with reference point. So like this, object 1 or the object in position 1 when you apply a force and moving to another position. Okay, this is the position 1, position 2. So this is mean motion, move or motion. Okay. When we learn about the force, so we must also like about the distance, speed, and time. Distance, speed, and time. We must know about symbol. Distance is s or space. Speed is v, and t time for t. The formula between distance, speed, and time is s equal v times t. I have an easier triangular magic to remembering about this formula. This is very important. Like this. We can put S in here and V over there. This C. So when we calculate S, it means S equal V times T. This is proportional position of in times. And this meaning this divide. So when we calculate about V equal S over T. And when we want to calculate about T equal S over V. This is V. We want to calculate V. We hide it. We close the V. So they appear S over T. And then when we close the T, this is S over V. So next, we want to keep learning about this distance, speed, and time by exercise. Okay. Okay. Next, we want to exercise about the distance, speed, and time. Okay. We can see there are some exercise. Number one, we can do first number one. Okay. Number one, we know from this side, Ruby covers 2 kilometers. So we know that's what's 2 kilometers. 2 kilometer it means S, not 2 kilometer, right? In 1000 seconds. Second, it means T, 1000 seconds. And what is her speed? So what her speed? So we can calculate by magical triangular just now. Remembering? This is S, this is V, this is T. So when we want to calculate about V equal S over T. But remember, S must in unit meter. We change conversion to meter, 2000 meter. So we calculate this S 2000 meter per T 1000 seconds. So meter second. So the result is you can cross this to easier for the calculating. This is you can found in math. So when you're doing the physics, you must be strong in math. This is so the result is 2 over 1 equal 2. So the velocity, the speed is 2 meter per second. Okay, number 2. Next, number 2. Aaron ran to the shop to buy FIFA 19 and travels at 50 for per second. How far does he go? Yeah. So what's noun? Noun is a travel. It means speed is 50 meter per second. And then how long? S equal 20 seconds. 20 seconds. So the question is what time? How long? How far does he go? Sorry, see, this is how far. How far is mean pace. S, yeah? Equal S equal V times T. So we can substitute V 50 times 20. So equal 1000. We can do this. What do you need? This is for remembering you to find the right answer. Meter per second and time 20 seconds. So you can cross this. Sorry. It cross this score 1000 meter or 1 kilometer. Okay. Number 3. Yeah, number 3. Oh my God. Number 3. Sarah drives her car at 40 meter per second. It means velocity 40 meter per second. Okay. Then how long does it take drive when pace is 20 kilometer? And the question is time. How long time? So just now we can see from the magic triangular T equals, so T equal S over V. But remember, we must conversion with same unit. Yeah. 20 kilometer equal with 20,000 meter. So we can input in here 20,000 per 40. This is meter over second. So we can cross this 1 m. So the result is, this is 20 divided 4 equal 5. So the result is 1, how many 0? 5, 1, 1, 2, 500, and the unit is second. Okay, easy? Yeah. Okay, next, we continue to the distance time graph. Yeah, you can see from the right side. Yeah, you can see there's what number? Okay, we discuss about number 1. Yeah? What is the speed during 20 seconds? So speed is V. Yeah, okay. V equal S per over T. So you can see from distance at the time 20. So we substitute this 20 second. Distance is 10. Like this. So this distance meter. So the velocity become, cross this one, cross, and result is 1 per over 2 meter per second or 0.5 meter per second. Okay, easy. Yeah. So next to number 2. How far? It means space. Yeah. How far? V times T. V, how many? V. So after 60 seconds. We can directly. Yeah, we can see as from graph. We can see from the graph at the 60 second, the distance is 40. This we can see directly from the graph. Equal of 40. It's 40 meter. Okay. Next, number 3. What's the speed during the last 40 seconds? The speed. Yeah. Speeds. It means S over T. Well, 40 seconds. We can see 40 seconds. 40 seconds during S 10. 40 seconds is 10. This is meter. This is second. So you can calculate this one. This is cross. Next result is 1 per 4 meter per second or 0.25 meter per second. Okay. Then, and then next, when was the object traveling the fastest? You can see there's when the faster from the graph. Yeah, we can see that it means the fastest is acceleration graph. Yeah, this is between number and at the point at the time 40 until 60 seconds. Okay, we can continue next for the exercise. Okay, we continue talking about the velocity time graph. Yeah, we can see from the right side velocity time graph. We can see this is x-axis, this is time, and vertical axis is velocity, meter per second. We discuss number 1. Yeah? How fast was the object going after 10 seconds? Yeah? We can how fast using v. Okay? V. So we calculate this S over T. Okay? After 10 seconds, we can see after 10 seconds. So T 10 seconds and S. How the distance? How fast? So we can see for the graph, distance velocity is 4. It's mean as no the velocity from the graph is 40 meter per second. Okay. Okay. Next, number 2. What is the acceleration from 20 to 30 seconds? This is acceleration. Yeah, from 20 until 30 velocity. This is with the acceleration from 20 to 30. This means 40 v per t. Yeah. V how many? 30 until this is 40. 60 minus 40 per this is over time 3 times 10. 30 minus 30 means 20 over 10 equal cross. This is 2 meter per second square. Okay, next number 3, the deceleration. At the point C. Yeah, number 3. What is the duration from 30 to 50 seconds? From 30 to 50 seconds. Same, yeah. But this from 30 to 50. So 0 minus v over t. This is v last v is 0 minus how many? Minus 60. Minus 60 over time is 50 minus 30. So equal minus 60 over 20. So we can cross the 0, become minus 3 meter per second square. Okay. Number 4. How far did the object travel altogether? How far? Listen. Yeah? This is very important. For the area. Yeah. So it's mean when we want to count about the far, it's mean we count about the area. So what the shape of the area or from A until C. Okay? This is we divide 1, 2, and 3 shape. Okay? Again, area 1 plus area 2 plus area 3 until area 3 plus area 4. Okay? Area 1 we can define this is triangle. It means half of base is 10 times head how many 40. Okay? Next plus A2 is rectangle is length times weight. Okay? So this is 10 times 40, and then area 3 is we can put B area B. We can triangle also. Okay? Half of base, how many base is 40 minus 20 is 20. Okay? And head is 60 minus 40 is 20. Next, the last one, this is a rhombus. This is the parallel side. Yeah, summary of parallel side. It means B N over D. This is how many 40 until 40 minus 30, so 20 plus and 30 divided to times head. How many head is 40? And 1 plus 5 is triangle. This one is. So we can count this 5. So 5 times 40 equal to 100. Okay? This is 400, and then this 200 plus this one 50 divided 2 is 25. Okay? 50 divided 25 times 40 equal 1000. So calculate this one. This is easier to make you failure. Okay? This is 60, this 100, this 1200. So equal 1800. So the far object is 1800 meter. Okay. Okay. Next we discuss about the momentum. Okay. What is momentum? Any object that has about mass and velocity. Any object has both mass and velocity. This is to make a momentum. So the relation between momentum, velocity, and mass is momentum symbolized by V. The formula V equal mass times V. This is momentum. This is kilogram. V in meter per second. So momentum is kilogram meter per second. Okay. Okay, we can exercise. What is the momentum of the following? Yeah? We can exercise. For example, when RC mass, a man has mass 50 kg, and then running at 10 meter per second. So our momentum, the P is so we can calculate this P equal M times V. So M 50 kg times 10, so 500 kilogram meter per second. Next, this is exercise number 1. Exercise number 2. Mr. Richard has mass 90 kilogram and bungee jumping with speed falling at 40 meter per second. So the momentum equal M times V. This is M 90 times 40. The unit is kilogram meter per second. This is equal 3600 kilogram meter per second. Okay, this is easier for this subject. We can make easy formula by magic triangle. Okay, or like this. This is very important. V equal M times V. Yeah. When we want to calculate about the momentum, we can close this. So momentum equal mass times velocity. When we want to calculate velocity is momentum over mass. Okay, thank you. Okay, we continue. We do the exercise. Yeah, this is very important to make you easier do the exercise. Okay, we can see from the right side. Yeah, you can see the exercise. Number 1, the mass of truck and its load is 70,000 kg. So this known. Yeah, mass equal 17,000 kilogram. Yeah? And the velocity is 13 meter per second. So the this is A, and number 1. So the equation linking momentum, mass, and velocity. Formula just now we still remember. Momentum equal mass times velocity. Okay. Next, number 2. They calculate the total momentum. Total momentum equal, we substitute from this noun, mass in kilogram. This is 17,000 and then times 13 meter. So kilogram meter per second equal is 220,000 kilogram meter per second. Okay. Next, B, the force in the road from what? Yeah. In the B, number 1. Yeah. You can see the force on the road from one of the tires is, so force is 53,000 Newton, and then the pressure of the air is 390 kilopascal. Okay. And then state the equation linking pressure. What's the formula? The formula linking force, pressure, and area is pressure equal force over area. Done. Yeah? Okay, next, B, calculate the area. So number 2, area equal, so we substitute for the noun, area equal force over P. So we can call it here. Area equal force 53,000, okay, over 390 kilopascal equal 390,000 pascal. Yeah? So we input this one. The unit is Newton and Pascal. Yeah? So area equals this one to easier. Okay, 53 divide 390. Okay, this one how many? 0.53 divided 0, 38. Yeah? So round it becomes 0.14 meter. Okay, next we do number 2. Yeah, number 2. A student is playing game with some empty tin. Yeah? It throws a wet cloth mass 0.15. You can write down 0.15 kilogram. Okay? And it is the wet cloth moves at velocity. Yeah? Velocity of wet is 6.0 meter per second. So the equation linking between mass, velocity, and momentum. Okay, this one number 1. So momentum equal m times velocity. Okay, next itu calculate the momentum of the wet cloth and give the unit. This one momentum equal, we substitute the noun of the amount of mass is 0.15 kilogram and times 6.0, so equal 9 kilogram meter per second. Okay, okay, we continue to B. We can see from the exercise, this the wet cloth stick to tin number 1. The mass of tin number 1 equals 0.05 kilogram, and then the wet cloth and tin 1 move, calculate their velocity. Calculate their velocity. Okay. How many? We can see from just now we already know the momentum of the wet is 0.9. So can V equal momentum over mass. Yeah, momentum equal 0.9 over mass is 0.05. Yeah, you can see this. How to calculate this easier? We can divide. Yeah, move right side, become the whole number. Yeah, okay. 1, 2. We remove the point. Move here. 1, 2. So this is become 5. So still also move 2 times. 1 and 2. So 9 and we add 0. Yeah. So 9 divided 5 equal 1. Remain 4. 40 divided 5 equal 8. So the result is velocity 18 meter per second. Okay, we continue. Sorry, this is from this just now this E1, this E2. Okay, from the number E2, we can now the students throw a bigger wet cloth at the remaining things. The wet cloth sticks to tin number 2 and 3. So this mass is number 2 and number 3. Yeah? And then move away together. The student concludes the velocity of tins 2 and 3 is same the velocity. We'll conclude, assume same velocity. Is it agree? No. We can see about this. The answer is no. Why? Because it is different velocity, different mass of M2 and M3. Then the matter bigger of cloth is different. So there are many variables, different variable. The velocity is not same. Okay. We continue to number 3. From number 3 we can see a golfer practice hitting balls on a golf course. A ball X roll along level ground as shown in the diagram. You can see for this. And number 1, we add the label arrows to diagram to show the direction of the two of force. Yeah, we can see, right? It's the ball. Yeah. What the direction? Yeah. We label arrows. Number 1, this one. This is weight. Weight is weight. Okay. And then number 2 is R, reaction. And then opposite direction is air fraction. Equal air fraction. And last one is the fraction. The fraction F mean fraction. So we can see there are 4 arrows direction. This number 1 weight, and then reaction, and then air fraction, and fraction of the length. Yeah. So this is I1. And so next I2. The mass of ball Y is 45 kg. Sorry, 45 gram. Okay. Next, the golfer gives the ball 36 joule. This energy 36 joule of kinetic energy when he hits. Yeah. And then state the equation linking kinetic energy mass. Okay. Linking energy. There is kinetic energy. Yeah. Kinetic energy is half of. We can calculate it. Yeah. Energy kinetic. Just now we give 36 joule. So kinetic energy is half of mass times velocity square. Equal energy kinetic. So we substitute this 36 and then half mass 45. Sorry. This is conversion to kg. 0.45 kg. So we 45 times 0 minus 3 and for velocity square. And then we calculate how many for velocity square. We can move it to 36 times 2 equal over 45 times 10 minus 3 v square. So we can easier to calculate by crossing this is 9 multiple. So we divide 9 is 4. This divide 10 5. And then this move to up, yeah, become 80 times 10 plus become plus, right? And then divide 5 equal v square. And we can cross divide 5 16. So 1600 v square. So v equal square root of 1600 equal 40 meter per square. Okay, I think that's all for your attention. Thank you for your attention today. See you next time.
Thank you for learning with BimbelQ. We support clear and structured understanding.